This is GATE 2022 question number 26. It states that if g of k is a Fourier transform of fx, then which of the following are true? So let us see the options. It states that g of minus k is equal to plus g star. The star represents the conjugate, implies fx is real. So all these options, if we see clearly, then there is a condition on fx, that is either this fx is real or the fx is purely imaginary. These are the two conditions on fx, and if fx is real or fx is purely imaginary, then which of these following options are correct? This is what we need to find. So let's jump into the solution. So it is given in the question that g of k is nothing but the Fourier transform of fx. This is what is written here. Now, definition of the Fourier transform, it is written here that the Fourier transform of fx is nothing but 1 upon root 2 pi. Sometimes we don't write this 1 upon root 2 pi. We just include 1 by 2 pi in the inverse Fourier transform because it's a pair. So it is better to write 1 upon root 2 pi. From minus infinity to infinity, fx e to the power minus iota kx dx. This is the definition of the Fourier transform of a function fx. Now, since there are two conditions which are there, that fx is real or fx is imaginary, these are the thing. So what I have done is that I have found out two cases. One is that if fx is real, suppose fx is real, there is no imaginary part, it's completely real. Then what will happen if the function is real? Then the conjugate of gk is g star k as defined in the question. So what will be g star k? If gk is nothing but, g of k is nothing but the Fourier transform, which is this one. This is nothing but g of k. Okay. So g star k will be therefore 1 upon root 2 pi minus infinity to infinity. If you take the conjugate, because the star is nothing but the conjugate, if we take the conjugate of fx, since fx is the real function, conjugate of fx is also equal to fx. But conjugate of e to the power minus iota kx is nothing but e to the power iota kx. Therefore, g star of k is 1 upon root 2 pi minus infinity to infinity. Fx remain as it is because it's a real function. If we take the conjugate of a real function, it will be same real function. But the conjugate of the imaginary part, like e to the power minus iota kx, suppose it becomes e to the power iota kx. Why we can write e to the power iota kx? Because if you further write e to the power minus iota kx, it can be written as cos kx plus iota sin kx or minus iota sin kx. Therefore, if you take the conjugate of this e to the power minus iota kx, we will get it as cos kx. Only the imaginary part sign will change. It will be iota sin kx. Therefore, this becomes nothing but e to the power iota kx. This we should be remembering. So g star of k is 1 upon root 2 pi minus infinity to infinity fx e to the power iota kx dx. This is what we are getting. Now, there is a condition. So g of minus k, let us see what is this. So g of minus k will be 1 upon root 2 pi minus infinity to infinity. This is a function of x, so it does not matter. So f of x should be as it is. But e to the power minus iota, now k is replaced with minus k into x. In which definition? In this. Because g of k is this, now we are putting g of minus k here. So k should be replaced with minus k. And this is what I have done. Finally, we are getting 1 upon root 2 pi minus infinity to infinity fx e to the power iota kx dx. And we have also found that g star k is also the same. Therefore, g of minus k is equal to g star k. That means that fx is real. Therefore, if we come to the question again, we can clearly see that g of minus k is equal to plus g star k, which we have found. And we have seen that it is true when fx is real. Therefore, this is definitely a correct option. Let's see, because which of the following are true, it is given. So more than one options might be correct. So we will see let us check the other thing, that when fx is purely imaginary, because these are the two conditions which are given in the options. So now if fx is purely imaginary means that some constant or some function times iota only. There is no real part. So here no real part. So if it is purely imaginary, then conjugate of fx will be definitely minus fx. For example, c is some constant, suppose, and iota c therefore will be a constant purely imaginary function. Now its conjugate will be minus c iota. Therefore, if fx is c iota, then it will be minus of fx. So conjugate of fx will be minus of fx, because fx now is a purely imaginary part. Therefore, g star k, if we again follow this definition of gk, then g star k will be nothing but 1 by root 2 pi minus infinity infinity conjugate of the entire function. So conjugate of fx will be now minus fx, which was not in this case. So it will be minus fx, and conjugate of e to the power minus iota kx is e to the power iota kx. Therefore, this is the now the g star of k, and this minus I have taken outside, and this is what we have got. Okay. Now we have already seen that g of minus k, we have already calculated g of minus k is 1 by root 2 pi fx e to the power iota kx dx, which is nothing but this particular expression. Therefore, g star of k is nothing but minus of g of minus k. Now this is true when fx is purely imaginary. So let's come to the option again. G of minus k is minus g star of k implies fx is purely imaginary. This is also coming out to be correct. But if you come here for purely imaginary, we have not got this particular thing, that is g of minus k is equal to g star of k. So this is wrong. And g of minus k is minus g star of k, fx is real. We have already found out that this is the correct condition. Therefore, this is also wrong. Therefore, A and B are the correct options. Therefore, gk, if it is a Fourier transform of fx, then if fx is real, then this is the condition. If fx is purely imaginary, then B is the correct condition. Therefore, A and B are the correct options for this particular question. Thank you.